Welcome to the Pretty Intense podcast. If you could please hit the subscribe button, I would really appreciate it. Today on the show is David Kipping. David is the Associate Professor of Astronomy at Columbia University and the Director of Cool World's Lab at Columbia University. I love the universe. I love the nature of reality. I'm eternally fascinated. Probably eternally is the right word because will we ever get the answers? Can we? Are we really even programmed to be able to answer the biggest questions? I'm not really sure, but that's what we delved into today and explored. Everything from our own planet to the universe, to our galaxy, AI, the types of civilizations, extraterrestrials, of course, getting off planet. And then literally just like, what do we hope? Like, what do we hope is our reality? Because there's so many potentials. And I think that, we kind of spun around on this sort of idea that we can even have these thoughts that we think some pretty big things. We feel like we know some pretty big things. And why is that? And what does that mean for us as humans? And what does it mean for our future? This is all about the nature of reality, our universe, and our orientation, and where we're going, and even where we've come from. David is just a brilliant guy that is a really good teacher. So if anybody is interested in learning more about the stuff that we talked about today, he has a YouTube channel called Cool Worlds. Get into science. Science is cool. Come on, be a nerd with us. Us meaning, at least I'm fascinated and he knows the answers. So check this out. Please hit the subscribe button, the thumbs up, and let me know what you think in the comments. All great athletes have one thing in common. They take care of their bodies. It's something that we do from a young age, whether we work out, the food that we eat, how we prepare our mind. This is all part of becoming a great athlete. And one thing that I do every single morning is I drink AG1. I do it before I have coffee. I do it before I eat any food. I really feel like for me, it's helped my gut health. It's made my stomach just feel like less bloated and more calm throughout the day. It handles all food so much better. I'm putting like 75 high quality ingredients into my body first thing in the day, which makes a huge difference. Even if I'm traveling, I use the travel packs. I was in Europe for 6 weeks. Every single day I put AG1 into my body. So if a comprehensive solution is what you need from your supplement routine, then AG1 is giving you a free 1-year supply of vitamin D and 5 free travel packs with your first purchase. Go to drinkag1.com/prettyintense. That's drinkag1.com/prettyintense. Check it out. You research the stuff that it's just so fascinating to me and always has been. Like since I was a young kid, it's just, I feel like so fascinated by the universe and how things work and what our place in it is. I wonder, like, what's your why? Like, why research the things that you do and what do you hope to find?
Yeah, I mean, maybe similar to you, all my life, it's been one of those burning questions. As a child, I remember lying in the grass, looking up at the sky, looking at the stars, and just wondering what else was out there. And, it's unusual because I think at school, we're told to pursue careers that lead to real jobs, right? So you should become an engineer, you should use your math to do that, or go into finance or something like this, or a lawyer. But I think, I was lucky to have mentors when I was young who realized that I was capable of it and there was a career path for me to pursue my passions, which was physics and astronomy. And I pursued those questions ever since, and it's always felt like doing a hobby. If I was doing another job, as I'm sure happens for many of the people, I think I would still be doing this on the side. And the burning question for me is just to really answer, are we alone? How does the universe work? What else is out there? It's just within my soul to want to answer those questions.
You feel like you're trying to prove it correct that we're not alone, or you think we might be, and you're trying to prove it that we are not? Like, what is your orientation in that mission?
Good. Yeah, I'm glad you asked that because people come in with a lot of preloaded expectations and judgments and decisions on this question. And as a scientist, we have to think about, what are we trying to do in science? We're trying to figure out truth, objective truth. And really that means letting go of your personal beliefs, your personal desires and wants. And in fact, trying to consciously leave those on the side as much as possible. So I really, as a scientist, when I'm asked this as a scientist, I always say, I don't know. That is not made the answer that is very satisfying to hear, because we're used to scientists being able to tell us the answer to all these questions in life. Why does the world spin every 24 hours? Why does the sun rise? Why does the sun set? What causes rain cycles? Having all these answers. But for this question, we really don't know. And I think it's just more honest to say that we have good arguments to think that we're not alone. You can certainly put forward a very convincing argument to that case, but you can also put forward some pretty good arguments to the contrary. And so I don't want to prejudge it. My job as a scientist is to look clearly with open eyes at the data and try to figure out the truth. And sometimes that does mean, because like I'm sure many of the listeners here, we want there to be life out there, right? Many of us feel that way. Some don't, but many of us feel that way. We kind of wish that there was someone else out there. And you have to almost push that aside and work against it. Whenever you see evidence that suggests this could be life, we have to sort of take a step back, breathe, and remember our own biases and try to correct for those. So I think about that question very actively as a scientist as to how to be fair and to be clear-minded and objective, which is ultimately our job.
What would it mean if we were alone? And what would it mean if we weren't?
I think it would be, at least for me, it'd be pretty earth-shattering, right? To hear that discovery either way.
I think it would be super shocking if we were alone. Super.
Yeah, I think a lot of people feel that way. And strange enough, it would probably be impossible to ever establish that. Right. So and that's kind of a curious nature of that problem. You can never basically disprove life. And that's a very weird thing about aliens. So one of the recent research papers that I'm working on actually points this out. There are 3 fundamental problems with looking for aliens. One is they can explain everything. So you could say, why is the sky blue? That's because of aliens did it. They flew in their spacecraft and they sprayed spray paint in the sky, and that's why the sky is blue. And some people might be satisfied with that as an answer. And then you could say, well, another problem with them is that they can evade everything. So you might say, hey, I saw a UFO on Monday, Tuesday, Wednesday. So I'll rock up and try to see it with you on Thursday, and I don't see it. And so my conclusion would be, you are wrong, but you might defend that and say, well, they don't come every night. Sometimes, they don't feel like coming, and so they're infinitely evasive. They could always evade detection. I think a more pointed example of that is looking at Mars. Like, we have been driving rovers all over the surface of Mars for years, trying to look for signs of life. We don't see anything, but we still can't disprove absolutely that Mars does not have life, maybe buried under this rock that we've just not turned over, or underneath the surface, or in some place we've not yet checked. And that's always going to be true, no matter how much, even when we have Martian bases, Martian colonists trudging all over the surface, we still won't be absolutely sure that there isn't some kind of life on that planet that just has been missed thus far. So that's an unusual feature. Most scientific hypotheses do not have that as a feature, that they are infinitely evasive. And also, subject to the whims of the alien, right? The alien might be shy, right? And so it could just not want to make contact with you. So both those things are very unusual. And it does mean that I think, coming back to your question, I think it's impossible that we'll ever prove we are alone. But I think we could amass growing evidence that we are at least unusual, and very, very rare, perhaps. We already have some evidence that is true. We look out into the universe, we do not see stars that are engineered. We do not see giant machines orbiting stars. We do not see galaxies that have been converted into giant structures. So as far as we can tell, everything about the universe appears totally consistent with a fully natural explanation. That does not mean there are no aliens out there, but it means they never get to that point, or at least they very rarely get to that point where they start engineering the universe and galaxies and stars themselves. And we have pretty good data on that. We know, like, 1 out of 100,000 stars we've surveyed, that is not true. So that's an interesting data point. But again, it doesn't disprove that they're out there in some. What about the other 100,000 stars? You need to go to 1 million stars to really disprove this. So it might be impossible to ever disprove it. On the other hand, let's say we did hit a success, and tomorrow we discover, compelling evidence. Everybody's convinced that we have life out there, which I think would be pretty amazing for many of us. it has the potential to unite humanity in so many ways, right? We'd stop seeing divisions between countries and borders and boundaries, and we'd start to see that we are just one people on this fragile little rock floating through space. And there's all these other people out there who are just waiting for us to join the conversation and to just grow up a little bit, perhaps. And I think that would be transformative to us. And that is totally possible. It's very possible there is still a galactic club out there who are waiting for something to happen on this planet to believe that we are worthy of detection or worthy of communication. And we certainly can't rule that out either.
The Galactic Federation. I think it
was good Star Trek.
Yeah. I mean, I interview a lot of people that are also very sort of spiritual and esoteric in their thinking, and they talk about the Galactic Federation. They talk about it. There's many people I've talked to that say that, but whether it's true or not, obviously, the kind of proof that we're looking for, I think that's the thing I always get a little stuck on, is like when we say there's no proof, when we can't explain how structures are built, we can't explain their mathematical sort of superiority, we can't explain their orientation with the stars, we can't explain certain things in the sky, we can't explain certain CIA secret programs that have existed since the 50s and 60s and probably maybe even earlier. But we can't explain these things. And this to me feels like some of the proof.
Yeah, it's easy to inject aliens into that which we cannot yet explain. And there is a very long history of doing that. And you give some good examples. I think UAPs are obviously the most sort of poignant example in many people's minds right now. Here is clearly a phenomena that we have pretty good evidence at this point. There's something going on, and pilots are clearly seeing something, and we don't understand what it is. One hypothesis, I would say, is that it is alien visitation.
Yeah.
I would not accept that is the only hypothesis on the table at this point. I think there are alternatives, and this is such a major claim. I think it deserves real confidence before we go gung-ho that this is the absolute solution. But there is a historical precedent, and that's why I'm sort of have trepidation about injecting aliens here. There is many cases where we have said there's something we don't understand, it's aliens. One of the most famous examples actually happened with Mars that we talked about earlier. So go back to 150 years ago, there was a very famous astronomer called Percival Lowell, who now he commissioned the Lowell Observatories in Arizona with his inheritance. He was an industrialist, but he got really into astronomy. And so in his later life, he built his own observatory, and he was obsessed with Mars. He was obsessed with it because at the time it was recently discovered that Mars had polar ice caps. So, and you can kind of see it if you get a few inch telescope or even a good pair of binoculars and you look at Mars, you'll be able to see these little whitish blue regions on the top and the bottom. And so scientists, when they saw that, they thought, wow, if there's ice, that means there's water. It looks just like the Earth in terms of this like little ball of rock hanging in the sky. So potentially there's life there. And Lowell had sort of, talked about prejudgment. He had prejudged there was life there. He was convinced. He even wrote books saying it's as assured that Mars has life in it as that the Pope's Catholic, that kind of stuff. So he was just totally convinced that, of course, it's stupid to pretend that Mars doesn't have life on it, which is the same kind of argument that we often hear people today say. Well, of course, there's life in the galaxy. Like how could there not be? And it was the same kind of thing. And it's not unreasonable to suggest it's possible that Mars has life on it. And so when he started to look at it very closely, he started to see these streaks, these lines across Mars. And so to him, the obvious conclusion, as in an industrial area, he was seeing canals going up all across America at the time. So he concluded there must be canal systems. What else could do this? What else could make lines across a planet except for canal systems? And so he was convinced there was a canal building Martian civilization on Mars.
Or roads or something.
And for years we thought that was true. I mean, or many people thought that was true. They were convinced it must be true because Percival Lowell, this very famous astronomer, said it was so. And of course, years later, we realized that actually most of them were mirages. They were caused by distortions in the telescopes and atmospheric effects. And then there are some geological features, of course, which also cause these lineae, they're called, across the planet. But none of it was canals. Of course, we know that absolutely. We've put rovers roaming around. We know there's no canal civilization there. But it was a classic case of we see something we don't understand, and we put aliens there, and it's God of the gaps, and we've done that for millennia. What causes the sun to rise? Must be a god. What causes the planets to go around the sun? That must be a god. What causes the water to fall from the sky? That must be the god of rain, the god of thunder. And we did that for a long time because we just couldn't explain it. And we're doing kind of the same thing, and that's what worries me with aliens. It's like a band-aid that can explain everything, so we just stick it on, and we forget to engage our brains a little bit and really go through all the possibilities.
Dark energy and dark matter, we can't explain that. There's something there, let's just call it dark.
Right. I mean, yeah, that's an interesting comparison. Dark energy, I would agree to some degree, feels that way. Dark matter and dark energy, they often get thrown together. Like, they're both dark. They're the same dark something, dark X, dark Y. So there must be kind of the same thing. They're very, very different. We know almost nothing at all about dark energy. And so I kind of agree with you that it is a band-aid in that way to sort of there's something there that we can't explain, so let's just call it dark energy. We have some physical motivation to think dark energy should exist. If you go to quantum theory and you look at empty space, you do predict that there should be this bubbling froth of foam of energy just popping into existence, and that vacuum energy is sort of what we think could explain dark energy. There's huge discrepancies between what dark energy we observe in the universe versus what quantum theory predicts. That's a giant problem. With dark matter, it's a little bit different because we have multiple independent lines of evidence for this stuff. And it really is just invisible stuff. It's called dark matter. It should be called invisible matter. That'd be a much better name. The initial evidence was taken by Vera Rubin, a famous woman astronomer who, is now, we've got should have had a Nobel Prize given to her, but I suspect wasn't because she was a woman. But she discovered dark matter in early evidence of rotation of galaxies. There is now going to be a telescope named after her. So fortunately, the Vera Rubin telescope. It was previously called LSST. It's an 8-meter US telescope that we're building, one of the largest telescopes in the world. It's going to be named after her. So I'm pleased to see that happen, to get some credit to her. But yeah, we started to see that evidence very early on from rotating galaxies. They're basically rotating too fast. So if you think about kids on a roundabout, on a merry-go-round, as they're clinging on for dear life to hold on, right? And if they let go, they'll just fly off if they spin fast enough. And the same thing's basically happening to galaxies. The vast majority of galaxies are spinning way too quick to hold on to their stars. The centrifugal force should be basically flying them off. So there must be something holding on to that matter. Yeah. It could be that our theory of gravity is wrong, and that was a very compelling counter argument for a long time. But as we've accrued more and more observations, we have independent lines of evidence, such as gravitational lensing. So if you look at you may have seen this in the first James Webb Space Telescope photos. There was this beautiful photo. I forget the name exactly of the image, but it was looking at a very, very distant part of the universe, and you could see the galaxies warped into kind of like a fisheye lens. You kind of see this warping around the central region, but there was nothing there. So somehow light is passing through this region and getting to our eyes. So it must be something that's transparent. And yet that transparent stuff is also bending the light. In other words, it must have gravity. So there's invisible bending stuff. So which is like another completely independent and very compelling evidence. There's just something there that we can't see. And to me, that makes perfect sense. Why should we expect that all matter in the universe is stuff that we can see? That's kind of almost arrogant to think that should be true. Like it's certainly quite possible there's plenty of light that we cannot see. So I think there's multiple lines of evidence. I feel much better about dark matter. It's not a closed case. I think we haven't completely removed the alternative theory of a modified theory of gravity. With dark energy, that's a big mystery, and there's lots to say about this. There's a crisis in cosmology right now where there's a lot of disagreement about dark energy. That's a really interesting open case. I think dark matter was starting to close in, but it's still not solved there either.
You're saying that based on the size of the sun and the energy that it has, or the size of that galaxy, that it shouldn't be able to hold the planets, exoplanets, it shouldn't be able to hold what it holds based on its rotation. But you're saying that might not be true. You're saying that's maybe not true, the actual how fast it's spinning, because of this because of the warping, or you're saying that the dark matter is holding it, and that is an element that we just don't understand how it can spin the way it does and keep everything intact.
Yeah, let me try and explain it another way. Yeah, there's definitely, you're on the right track there. So let's imagine we're talking about the galaxy, but let's talk about our solar system just for a moment. Our solar system doesn't really have much dark matter in it, but let's just take that as a case example. Mercury goes around the sun. It's the closest planet. And it actually, the closer you are to the sun, the faster you orbit around. It's kind of the same as a penny drop. You know, those charity penny drops where you throw the coin, kind of goes around. So, and then as it gets closer, it speeds up as it goes down. Same thing with planetary orbits and gravitational orbits in general. So Mercury's moving pretty quick. But what if we observed it to be moving too fast? It was moving even faster than what we currently measure it to be, like maybe 2 or 3 times faster. That'd be very puzzling, because as far as we can tell, it should just fly off in a straight line, right? Because if you put speed boosters on the back of Mercury and you pushed it off, it would just fly off on a tangent, basically, and just leave the solar system altogether. But it's not doing that. It's moving still in a circle, but way faster than it should be, and gravity shouldn't be able to hold on to it. The gravity of the sun shouldn't be able to hold on to it. So the only explanation is that our mass for the sun, or our theory of gravity, is wrong. It has to be one of those two things that's in error. So certainly we're open-minded to both those possibilities. And the same thing is true for the galaxy. There is kind of the center of the galaxy where there's millions of stars, or billions of stars, in fact, all within this central bulge. And stars like the sun orbit around that at tens of thousands of light years away, and we orbit around. And I guess the observation is that the sun and other stars like it are moving too fast. Given their speed, they should all be flying off. That they should be going off in a tangent. So there's more gravity there than we thought there was, or our theory of gravity is wrong.
So it's in relationship to the sun, or is it in relationship to other planets or other exoplanets, or whatever the things would be spinning around it? Is it in relationship to those, or relationship to the size of the sun that you're saying it's spinning?
It's not really. The sun basically doesn't really. We don't have any evidence for dark matter in terms of the sun. We think that dark matter is too diffuse to get bound to solar systems. We think it's this kind of very light, fluffy stuff that doesn't really concentrate in the same way that ordinary matter does. So it's like a big fluff cloud in the galaxy. So the evidence is really by looking at galaxies, not planets, not individual stars, but the ensemble of stars. And when you look at all of those stars going round the center of their galaxy, you see collectively they are all moving quicker than they should be. In our own Milky Way, it's a little bit harder because, we live inside the Milky Way. So how can we see what's going on from the outside? We don't have that perspective. But there's completely independent evidence for dark matter there. So actually, one of my colleagues in my department, Catherine Johnston, leads this work, Professor Catherine Johnston. And we noticed there are these mini galaxies, these dwarf galaxies, and even smaller than that, just clusters of stars, which orbit around the Milky Way. They're very distant, but they're orbiting around us. And instead of going around in a nice compact ball of stars, they're being shredded into like spaghetti and being stretched out into streams of stars. Now, we think we understand when that happens. If you think about a black hole, if something falls into a black hole, you might have heard of the effect of spaghettification, because the gravity is so strong, it pulls you apart. So if you were falling feet first into a black hole, your feet would be close to the black hole. And so they'd be pulled down harder than your head. And so this would actually stretch you. And that'd be a very painful death, of course, to go out that way, but maybe better than falling into the black hole in some respects. So we think that's probably what would happen if you fell into a black hole. And we see the same thing happening to these stars. They're being spaghettified, but they're really far out from the Milky Way. So by all accounts, this shouldn't be happening to them. So there's obviously way more gravity there than there should be, which is, again, a very strong indication that there is dark matter, not just within the Milky Way, but actually completely encompassing the Milky Way. Probably the volume of dark matter is way, way bigger than the galaxy itself, probably like 10, even 100 times larger. And we are this tiny little thing. We are like the seed inside the true galaxy, which is this giant halo, as we call it, of dark matter. And that's what's ripping apart all of these clusters. So again, another completely independent line of evidence that's very difficult to explain. And you might be able to explain one of those things with an alternative theory of gravity, but it's very hard to explain all of them with the same alternative theory of gravity. It just doesn't really work. You kind of have to have a bespoke theory of gravity for every galaxy and every effect, whereas dark matter kind of cleanly explains everything in one go. So we still want to collect a particle. I want to hold it in my hand, right? I'm sure we all do. We want to have scientists detect the actual particle. We can, probe it. We can obviously not really see it, but we can at least know for sure it's in this little jar and something and poke and prod it. We haven't been able to do that, but we're convinced that there must be something out there, and it's hopefully we will detect it eventually. And if we don't, that would also be amazing, because it would mean we were on the total wrong track for 50 years, and there's something even more extraordinary out there.
Yeah, exactly. So I've thought many times about many odd things, and sort of conspiracy thoughts. Okay, and I think about like a sun or a source, right? The source of light. You think, okay, I walk outside and I'm outside, like it's clean, it's fresh, it's open, this is life, right? And then, I think about, what if Mars, they went inside of Mars? If you're able to create a space, I mean, we've even found really crazy civilizations that have built underground systems where they've lived. I think there's maybe one in Turkey or something like that goes so many levels down. So you think, and then of course all the other things about inner Earth or the moon or all these other concepts that are out there and crazy. And I thought, how could they live? Like, how could you go inside of something and live? But what is it that constitutes this star, the sun, to be able to give us life, to make me feel like I'm outside, to make me feel like I'm breathing and I can flourish? What is it? Like, can it be made on a smaller scale so that it is inhabitable inside of something and it still feels like you're outside?
Yeah, there's a lot of like really interesting things to talk about there. So the sun, the reason why the sun, of course, produces energy is because it's a big nuclear fusion energy plant basically in the sky. So it's producing huge amounts of energy by fusing hydrogen into helium. That's what's producing all the light and all the warmth and all the energy we receive. So could you mimic that reaction on Earth? Sure. Yeah, we actually have already done that. We've not been able to do it in a way that's self-sustaining like the sun does it, but we can do it momentarily. In fact, just this last year, the NIH has been releasing some interesting new experiments where they've been able to use lasers to compress little pellets of hydrogen and fuse them for very brief, like nanoseconds of time, even shorter than that. And that produces actually a net energy surplus, but it's just momentary. We're getting to the point where I think maybe we can imagine a nuclear fusion reactor at some point. If you want to produce light that feels like the light you feel on your skin when you're outside, you probably don't need a nuclear fusion reactor to do that. You just need like light bulbs which mimic the sun's spectrum, which isn't as easy as it sounds, but is again probably technically doable. And then you could power that some other way. You could have maybe a nuclear fission reactor instead, or you could have just a giant battery or something, some other way to power that system. And then if you wanted to be inside an object, and make it sustainable, you'd have to have an energy source to supply maybe these grow bulbs, these kind of lights which mimic the sun spectrum. You could have like a hydroponic system inside that object where you're growing plants and agriculture inside. And so that could be potentially sustainable. And in fact, there are some arguments to think being inside is advantageous. So for instance, if you wanted to colonize space, there's a huge number of asteroids out there, and some of the asteroids actually contain more rare earth metals than we could ever mine on Earth by such a large factor that just one of them would be worth like $1 quadrillion, which is way more than GDP of the entire planet if you just mined one of these. So maybe in the future, and other civilizations may have already done this, they move to these asteroids and they mine them. And as you mine them, you could carve them from the inside out, because that's where all the precious stuff would be. And then if you spin up these asteroids, you make them spin fast, and you imagine you're on the inside of that asteroid, it would create like a pushing effect, because again, the centrifugal force, like driving the car around, banking around the corner, you'd feel being pushed to the side, as I'm sure you're familiar with. And you would, that same effect is like artificial gravity. So it's quite possible that asteroids could be carved out from the inside, and then they'd be spun up. And then that would create both artificial gravity. You could have a power source that would you could grow plants in. And so it is quite possible. And obviously, if you've seen The Expanse or read the Expanse books, they kind of play with that idea. There's, I think, some of the in places you visit in the show are indeed these asteroids which have been carved out that way. For a planet, it's possible as well. I mean, Mars, one problem with Mars is that you get a lot of radiation on the surface. I think you would die of cancer fairly quickly if you lived on Mars because the radiation level was hitting you. And so one solution would be to go underground. You could also, put huge cement structures above your head, but that's going to be very expensive to do. It might just be cheaper to go underground.
Right.
And on the moon as well, that has been proposed, there are these lava tubes. So even though the moon is not volcanically active now, in its early history, it was volcanically active. And if you go to Iceland or Hawaii, there's these lava tubes you can, if next time you go, you should do a tour. They're really fun. These like thin tubes, look like a giant worm, has sort of eaten through the earth and created these smooth round tunnels. And they're naturally there on both the moon and probably on Mars as well. And those are like cathedral-sized spaces where you have natural protection from solar radiation, and you could hermetically seal it off and just have an atmosphere in there. And that would be the perfect place for a lunar base. You don't have to build any structures. You just have to seal the two ends. And
you just said it. There's a lunar base inside. You just said it.
So I think, being inside makes a lot of sense. And of course, the challenge that if civilizations do that, it makes it very difficult for people like me who are trying to detect those civilizations, because then they become invisible to a large degree. So I hope they don't do it, but I can imagine good reasons why they might do it.
Right. Well, it seems like it would check a lot of boxes. It's consistent, it's predictable, it's safe. I mean, I'm guessing that the extraterrestrials are looking at us, as I see in the funny memes of like, they're still trying to kill each other down there. Not yet. They're
still living overground. What are they thinking?
What are they thinking? Like, this is so volatile. They're getting sunburned. So just to understand that we have that level of intelligence to comprehend a way to engineer that, I think speaks volumes, and is just a very exciting thing to think about. And I've often wondered, though, when we talk about science, and you talk about gravity, and you talk about do we need new gravity or new math or a new way to look at things based on where it is we're looking. And with the evolution of science here, I wonder if as we evolve consciousness, and if we evolve as a species, do we reach a new level of math? Like, do we break through into another dimension, which maybe then we should talk about dimensions first and what you know about that. And then is that part of evolving, is that we sort of go, okay, this doesn't work anymore. It's too simple for our level of awareness and where we're at. And we need new science now. We need new numbers.
Yeah, I worry about that a lot as well. That it's the things that we think we understand so much, but it's the things that we can't even comprehend that we don't understand, that may be out there beyond our reach. And the things that we think are impressive may not be. I mean, in Star Trek, I'm kind of a Star Trek fan. I remember the kids at school in that show, they're learning calculus. There's like a throwaway line in one of the episodes where like the 5-year-old's learning calculus, and to us, that's just like, what? The 5-year-old can do calculus? That's crazy. But maybe imagine what those kids are capable of as they get into their higher education. I really want to quote, I'm just going to steal this, it's Neil deGrasse Tyson.
Yep.
Because he says it so beautifully. So full credit to Neil for saying this. But he says it so beautifully on this YouTube clip about how, imagine, our intelligence level compared to a chimpanzee. We are less than 1% difference in genetic material, right? So 1% difference in DNA. That's it. And from that 1% difference, you go all the way from the most simple tools of like sticks and rocks, and maybe barely even that with chimpanzees, and some kind of sign language. Like, you can get the smartest chimpanzee in the whole world and teach it sign language. You roll it in front of scientists, and we all kind of applaud, like, wow, isn't that cool? My 5-year-old can do sign language, and this smartest chimp can do that. Now imagine you go in that same direction again, another 1% along that vector of intelligence, just 1% difference from us. That intelligence level would be so different that we would be, rolling in front of them as smartest human beings like Albert Einstein, Stephen Hawking, and they'll be doing astrophysics in their head, and they'll be like laughing at that, thinking, oh, isn't that cute? Like my 4 or 5-year-old is starting to do astrophysics in their head, and their smartest individual can just do that. And then that makes you wonder that all the stuff that we think is impressive, like the James Webb Space Telescope and all the, the silicon conductors we've built, the transistors, the iPhones, all that stuff that we think is technologically impressive is just basically garbage to them. Like they just do not think
it's
that's
putting like
impressive
circles in a circle hole, and so a square goes in a square. Right. It's like, you're doing so good.
It's the sort of thing their kids are doing for fun, like just messing around with stuff outside. And so that worries us, because to those civilizations, they probably have very little interest in us whatsoever, and we would be like the ants, right? I mean, you don't stop and try and have a conversation with an ant in the street. In fact, you really don't even feel any sympathy for them if you tread on them. At least most people don't. Or if if you wanted to build a building and there was an ant hill in the construction site, no one would care. They would just knock it down and put the building there. And I think that's the case we kind of worry about. Is it's not that they're malevolent to us. It's just that they really don't care about us, because we're just so unevolved compared to them that it wouldn't even cross their mind twice to delete our planet if that was in the way of them doing some project they're interested in doing. So I think that's a little bit more terrifying. But I don't think it's very likely we're going to hear from those people. I don't think they're going to be trying to communicate with us. Probably the ones that are going to communicate with us are the ones that actually, if anything, are a similar level or even behind us. I kind of have this crazy hypothesis that I think the most likely communication we'll have will be with a civilization on its way out. One that's desperate. We listen, but we do not communicate really much into space. We don't have an active program of sending out messages saying, hey, we're here, can please come hang out with us. There isn't, there's a few individuals which are interested in doing this around the world, but it's pretty controversial. Stephen Hawking famously hated the idea of doing METI. He thought it was crazy dangerous. We should definitely not be sending out messages. We should just stick to our own world until we've sort of got very mature. But I think Stephen Hawking might have changed his mind if we were a civilization that was on the verge of collapse. And we knew in the next 100 years, with fairly good certainty, this is it. We are just not going to survive. In 100 years, we're done. And so we might, in that case, be more compelled to send out messages asking for help. Because what's there to lose? If you're going to die anyway, what's the loss in sending out a cry for help? And so those civilizations, I think, are the ones we're going to hear from first. They're not the ones that are super advanced, who've got it all solved, who are these galactic club members, who are super benevolent. They're the ones desperate, who have gone through nuclear wars, extreme climate change, whatever it is, and they are just pleading into the dark. And maybe it's not even a plea, but just a message to say, hey, this was us. Like, this is what we did. This is who we were. We just don't want to be forgotten.
Don't forget us. Yeah. Or we have resources of some kind on this planet, which I think is some of those conspiracies of ancient times of what brought certain civilizations or certain extraterrestrials to this planet, because there was certain elements, things to mine for them here on this planet that they needed for theirs.
Yeah, I mean, the thing is with resources is that the Earth is not particularly uniquely endowed with any special resources. So it becomes a little bit hard to understand why someone would go to so much effort to come to the Earth. We're a fairly ordinary planet in terms of our composition. I mean, Mars and Venus have basically the same composition as the Earth. And indeed, that's true. You can look at all the asteroids. They're richer in those elements, in fact, but they have the same basic stuff in them. In fact, if you really wanted to get as much rare earth metals or whatever it was as you wanted, an asteroid would make far more sense. As I said, this is way easier to extract that material than from a planet. The only case you might make is, well, Earth has water, so that seems somewhat special. But Europa and Enceladus, Mars, and many of the Pluto even, and many of the icy moons all have plenty of ice and water as well. And that's just the solar system. Why would you travel hundreds, tens of light years across space to get water when it's one of the most abundant things in the universe? It doesn't doesn't make a lot of sense. So I think it's hard to find any, if we had a very unique, in Star Trek, there's like deuterium. Again, come back to Star Trek. There's like this unique thing they use for their star drives called deuterium that only a few planets have. And so if we discovered something like that, I'm pretty sure that doesn't exist because it's a sci-fi concept. But if we did discover something, maybe it would make more sense why the Earth might be uniquely useful. The most useful material we have is life. That's the most special thing about Earth. I mean, we clearly are a planet completely governed with life, and that appears to be at least unusual, maybe extremely rare, and that is potentially much more of a, I don't know how that would be a resource, but it's potentially much more valuable and unique than anything you could dig out the ground.
How are we any different now from our sort of primordial soup that is believed to be our original ingredients, like the ingredients of the universe from as far back as we know? Which, that's also another question, is we're twice as old of a universe as we thought we were.
Well, that was claimed recently. I think that's probably not true, but that was claimed recently. But we can talk about that. Just a little
off.
Yeah, just off by a factor of 2. That's to astronomers, that's not that bad actually. Okay, factor of 2. Order of magnitude, you're okay. Let me take the first one first. So how's life changed? The actual stuff that life uses, it's difficult to know whether we're using different elements or different atoms and molecules than we were when life began, because no one was there. We don't have any biological samples of the very first life. We don't even really have any fossils of the first life. And of course, even if you do have a fossil, once you go through to sort of stromatolites, like the first fossils you start to see, that's just an imprint, right? So there's no actual biological material you can sample to really figure out the true full chemical abundance of those organisms. But I suspect it really hasn't changed that much. It's just sort of rearranging the same kind of stuff in more and more intricate and elaborate ways. It is interesting, I think, that life has got more complex over time. That's because normally in physics there is a process of going towards more disorder. We call this entropy. So if you build a sandcastle, like a very ordered structure, and you walk away from it, come back the next day, it won't be there. The wind will have withered it away, or the ocean would have washed it away. And that tends to be the way the universe, it just wants to get rid of structure and complexity, and it just kind of wants to make everything homogeneous and boring and flat. And that's kind of tends to be the laws of physics. Whereas evolution is almost the opposite. For 4 billion years, there has been growing complexity in all of the strings of life. That's really an interesting feature of life. It seems to fight entropy inherently, which is something that Erwin Schrödinger, who developed a lot of the quantum theory, he wrote a treatise about life. He pointed that out. It's kind of an interesting feature of life. And then this growth of complexity, it's gone through, of course, many different stages. I'm not a biologist or an evolutionary biologist, but certainly we think about it when we look for life elsewhere. I think, to me, the most profound thing about the story of life is that, we are looking, when we look at other exoplanets, for signatures of things like oxygen, things for like methane, things that life produces on this planet. And oxygen is produced by photosynthesis, but photosynthesis is a relatively recent evolutionary development. So it was only about 1.5, 2 billion years ago, I think, that we started to see photosynthesis develop, and oxygen only started to get into the atmosphere at significant levels around about just over 1 billion years ago. And so the Earth is 4.5 billion years. So you have about 3 billion years where there was nothing even on the surface. There was no multicellular life. There was no plant life. Everything was single-celled, and everything was living in water or in oceans.
But the whole planet wasn't water, right? But the only life that there was in water. Correct.
Yeah, life hadn't made its way onto land, as far as we can tell, until not too long before the Cambrian explosion, when life really started to propagate onto land. You started to get plants and trees and things like this. And so it seems like the vast majority of Earth's history, there'd be nothing really to look for. And yet that was how life spent most of its time in terms of its history. And guess what? There's only less than 1 billion years on the clock before we'll become uninhabitable again. And so the episode when planets like the Earth, at least, present a detectable signature of life is pretty brief. And it's even briefer if you consider us. Of course, we're just like a blink of an eye in that. So if you're looking for solar panels or satellites or rocket ships or something as your signature of life, that's an even shorter period of time that you're looking for. Like, you have to be so lucky to be contemporaneous with that. And so it is a challenge that there could be millions of worlds out there that are teeming with life. And again, come back to that problem of proving life. And we just can't tell. And maybe the only way to tell would be to visit it, to scoop up a sample of water, and then to, like, put it under a microscope.
Yeah.
We're a long way from doing that. But that might be, unfortunately, what we have to wait for getting that convincing evidence, unless we're just very lucky and we happen to sync up with another civilization or something.
Why do we feel like we're so special?
There's two sides of the coin to this. There's many astronomers have a knee-jerk reaction to the idea of us being special, and that's born from history. Because if you go back to 500 years ago, it was widespread knowledge that the Earth was flat, that the Earth was the center of the universe, that all the planets went around the Earth, including the sun was a planet back then. That's where our 7 days of the week come from. Sun, Sunday, moon, Monday, was also a planet. And so that was the wisdom at the time. That must be true. And so our knowledge increased over time, and we started to realize, actually, the Earth is not the center, the sun is the center. That makes much more sense. And then we realized, actually, no, the sun is not the center, it's going around a galaxy, but the galaxy is the whole universe. And then we realized that wasn't true either. Our galaxy is just one of many galaxies, in fact, billions of galaxies. And now we're even starting to contest whether our universe is unique, and there may be actually other universes and dimensions and planes as well on top of that. So it's been Carl Sagan describes it as a great series of demotions, right? So we thought we were the most unique, special thing. The universe was built for us. And bit by bit, that ego
becoming
was
an ant. Away. We're becoming an ant.
Yeah, and it's that is the mediocrity principle, it's sometimes called, or the Copernican principle, that we are nothing special. There's nothing special about where we live. And so that's why a lot of people think there must be life out there by that principle. But it's a little bit difficult with life, because you can't say what happens here must be typical elsewhere. I'll give you an example of a good use of the Copernican principle, the mediocrity principle, and that would be the planet Neptune. The planet Neptune has basically no bearing on us whatsoever. It really doesn't matter if Neptune was there or not there. We would still be here irrespective. It really has no influence on the Earth. And so it's not unreasonable to look at the fact we have two Neptunes, basically Uranus and Neptune, and say the fact we have those means that other solar systems probably have Neptunes. And you'd be right. Neptunes are everywhere. The fact they're probably the most common type of planet in the universe we've discovered over the last sort of 20, 30 years. So that's correct. That'd be a correct use of it. But now let's try and do it for the moon. Okay, so we have a big moon, but we are the only planet in our solar system to have a big moon, as far as we can, relatively compared to the planet. And lots of scientists have suggested that our large moon might be the reason we're here. Because if you didn't have the moon, you'd have much smaller tides. Those tides may have given rise to tidal pools where life in that primordial soup first got going. The moon also stabilizes the axial tilt of the Earth. If you took away the moon, Jupiter takes over, and Earth's tilt starts to go wonky all over the place, and we get these crazy seasons and very hectic climate. It also probably stripped away the upper lithosphere when it impacted. There was an impact that formed the moon, and without that, we might not have had plate tectonics, which are fundamental to the carbon cycle and which life requires. So there's many reasons why we think, okay, having a big moon seems important for our existence. And so in that case, you can't say, the fact we've got a moon like that size moon, at least, it's about 1% the size of the Earth in terms of its mass. We can't really say that means that all planets have those moons, because the only reason we are here might be because of that moon. So maybe only 1 in a trillion Earth-like planets have those large moons. And it's not coincidence we live on the one that has it, because we couldn't live on the other one, since they would never be capable of life in the first place. So that's where the Copernican principle falls over. You can't apply it to things where your existence depends upon that thing you're talking about. So we have to be careful with it. And that's why, we talk about this, are we special, are we unique? That's an example of what we might call the rare Earth hypothesis, that the Earth might be incredibly unusual. Perhaps the conditions which gave rise to life on this planet were 1 in a billion, trillion, quadrillion opportunity. And therefore, it's no surprise that we live on the planet where that happened, because, of course, we couldn't possibly live on a planet where that didn't happen, since there was no life there to begin with.
Right.
So this is called the weak anthropic principle, and it really obfuscates our ability to do statistics. You can't normally with statistics, say you've got one of something, there's probably many. You just can't do that for life, because we're only here because life got going. And so we kind of get this kind of chicken and egg type logical problem when we argue about it. So it is possible that life is very unusual. It is possible it's even unique within the observable universe. And even if you don't buy that, it's possible that intelligent life maybe life gets going everywhere, but intelligent life is an incredibly unusual adaptation.
Yeah.
And you think about things like eukaryote cells. We're all made of eukaryote cells. And there was this, the development of eukaryotes was this incredibly unusual evolutionary development where essentially two bacteria interacted with each other. One was mitochondria, which is sort of an energy producing cell, and it got gobbled up by another one as it was trying to eat it up for lunch. And instead of consuming it, they started to work together. And that formed a new thing that had never existed before. And we just don't know. Was that incredibly unusual, or would that have happened anyway? Was that like an inevitable thing that would have happened at some point? These are questions we don't know the answer to. And that's why I think we should be open-minded to the possibility that it could be an incredibly rare set of circumstances that led to our arrival.
When I research and follow my curiosities about all these things, there are a lot of people and scientists of sorts, whether physicists or astrophysicists, that I hear talking about how the likelihood of us being here, and I can't wrap my head around the numbers. It just doesn't compute with me. But they're basically like, it's impossible, basically. There's no way that we have the perfect amount of oxygen to breathe, nitrogen, all the important elements for this planet, that they stay in balance. The likelihood of us being here is just, it must mean that there is a God of some sort. So when you hear that as a scientist, like, does any of that resonate? And what is your comeback on that? I mean, you've kind of laid some of it out.
I would say very simply, the alternative explanation to God doing it, which is always kind of, I'm always want to shy away from that, just because it's, I'm not religious, but I think it's a little bit intellectually lazy to do that. Whenever you encounter something you can't explain, God did that, aliens did that. It's just it's not really in keeping within the scientific idea of trying to like come up with an understanding of why things happen in the universe. It's just like saying, well, magic did it. And that's not very satisfying. And there are certain questions where you do hit that wall. Like, you talk about what caused the Big Bang, and you get stuck. Science is stuck at questions like that at this point. We don't really have a way of, you go through those whys, and you will get stuck within about 5 or 6 whys, pretty much down any thread. You'll get stuck at a certain point. But I think the obvious counter is the reason, you could say these things are incredibly unlikely. And I think you can make a good argument for that. We don't know that that's true. For instance, one of these small probabilities would be the probability of making a protein. A protein is made of amino acids. If you put amino acids into a test tube and wait for them to make a protein, it just never happens. And the probability of it happening is something like 10 to the minus 40, which means it should just never happen in the universe ever, really. But basically, it's such an incredibly improbable arrangement of these jigsaw pieces to come in the right way. It should just never happen. But you might say, well, you don't actually have to have all the way up to a protein. You could have some intermediate structures that sort of precipitate the next level, and that precipitates the next level, and it's sort of self-catalyzing, we would say, in sort of chemistry terms. We haven't identified such a pathway yet, but it doesn't mean that one doesn't exist. Just putting stuff into a test tube for a few hours in the laboratory doesn't mimic millions of years of all the huge land surface area of the Earth. You can't really reproduce that in a laboratory setting. So we certainly can't rule out that the probability is much higher than those naive calculations might suggest. But even if those numbers were true, I would still not accept that as evidence of God, because it trivially must be true that we live on a planet where that success happened, because obviously we have to necessarily live in a planet where life got going. We can't, by virtue of being life, live on a planet where there is no life. So it is it's a logical fallacy to say that it's a possibility that it could be otherwise. It has to necessarily be so. And so in a universe that, as far as we can tell, is consistent with infinite, there's the observable universe, which contains around 10 to the 22 stars, but it probably goes on far, far, far beyond that. With enough volume, basically everything will happen once, in fact, infinite number of times. And so it's, to me, I see no inconsistency why the event could be incredibly rare, and we are that instantiation of that event, because that must necessarily be true.
Even when you say God, it's still saying something that you don't understand.
And then you have to say, well, where did God come from? There's all that kind of whole philosophical arguments. Yeah.
Maybe something that seems more tangible to talk about is, or philosophize about, is the likelihood of us being in a simulation versus a based reality.
It's something we have taken fairly seriously since Nick Bostrom wrote his famous article proposing this. Of course, it's not an old idea. People have been thinking about, even in, like, I think there's a Chinese story about believing you're a butterfly when you're asleep, and then when you wake up, that's the dream. Like, what we think now is dreaming, and the dream world is the real world, sort of thing. Sort of playing with these ideas of what's real and what's not. This is kind of a modern version of it. And of course, it's motivated by the enormous improvements in computational power, and especially looking, if you play any modern computer games, they're getting pretty close to looking like movies at this point. And so it's not a million miles off being able to imagine a virtual reality environment that would be indistinguishable from reality. And the step further would be that you could somehow upload your brain into such an environment, and you would never be able to distinguish the difference. So it's an interesting argument. Like so many things in these kind of discussions, it is a unprovable hypothesis at this point, and remains, in my opinion, I'm again pretty agnostic to it. I'd say it's possible. I don't see any evidence for it being so. It does have a potential problem that it's unprovable and untestable. If the simulation is perfect, there's nothing to look for, right? There's no errors in the code anywhere. If the simulation is completely perfect, then it would be basically impossible for us to ever detect that. And so if it's not testable, it's not science. That's kind of a definition of science, is that the thing you're talking about must be testable. Otherwise, this belongs in philosophy departments and not physics departments. That's a little bit of a get out clause, because you're just saying, I don't have to think about this because it's not testable. But it is kind of true that the bedrock of science has to be that you can prove an argument. If you can't prove the argument, then we're just going to spend the rest of eternity arguing about it. That's all it's going to be. And that's not really what science is interested in doing, wants to find answers. So I think, I wrote a paper about this a few years ago, and I kind of highlighted that, in a world where simulation hypothesis was true and simulated realities exist, there would be one true reality, base reality, that could be this reality we're living in right now. And therefore, maybe 10 years, 20 years, we'll invent this technology and we'll create all the simulations. Or we are one of these daughter realities. Someone else has invented this technology, and there's millions and millions of these things. But there's really two, it's important to detach that there's two scenarios. There's scenario A, where that technology is never invented, either because it's not possible, it's not, civilizations never have the compulsion to do so. It's considered unethical in some way. I mean, there are ethical problems, right? Sure. People are suffering on this planet. Many people suffer on this planet. So you are creating a simulation of suffering for many people. And some people might object to that. You're creating conscious beings that are designed to suffer. That seems a little bit pathological as an experiment. And so those simulations might not ever, there's a world where those simulations never occur. And so you have to give that credence as a hypothesis. The alternative hypothesis is that, Elon Musk and others are right. This will happen one day. We'll invent this technology. And then if that scenario is true, then of course I agree. If that scenario is true, it's almost certain we live in a simulated reality, because there's just far more simulated realities than base realities. But we can't say that that is true, because we haven't proven that simulation technology is possible or would ever be executed, even if it was possible. So we have to really wait to see what would come in the future of technology. And so in my study I wrote on this, I just said we have to give these two scenarios equal probability footing at this point, because it is a complete unknown. And that's usually where you start with. You give everything 50-50 odds. It's just saying, like, if you're going to pick a random bottle of Coca-Cola off the shelf, is it going to be Pepsi or Coke? It's 50-50 odds around if you just blindfold, you went through the store. And if starting from no information whatsoever, which I claim is kind of true in this case because we're predicting the future, we have to give these equal credence. And if that is true, there's actually 50% of your universe is true reality, base reality, and then 1% over here in terms of the simulated universe is true reality, and 49.99999, the rest of it is all simulated. And so it's actually slightly more likely that you would live in simulated reality just with the present information that we have. But all of that would flip were somebody, the day that, scientists chink their glasses of champagne because they've invented the first true simulation that's undistinguishable from reality, the day that happens, the odds change. And then it's almost certain that we do live in a simulated reality.
I mean, with Chat GPT, with deep fakes, and then just video games as an example, there's just so many ways that we can look and see how something artificially created can be indistinguishable to a large degree.
It's certainly getting that way. People are still arguing about AGI, artificial general intelligence, I think there's reasons to be skeptical that the LLMs, the large language models that underscore what ChatGPT doing, are ever going to realistically produce an AGI. That's not my field of expertise, but I'm keeping a close attention to that conversation. And there's certainly strong voices on either side that argue that the technology they're using just will never get to that point because the training volume is so large, they're basically running out of training data at this point. They've already consumed almost the entire internet. It's getting difficult to imagine how you could, it's so inefficient compared to a child. A child can be shown 3 or 4 items and then easily be able to predict the 5th, whereas these LLMs have to be shown millions of examples before they can make a successful prediction. So it seems like it's a long way off the kind of intelligence that we have that can learn things from very few examples. These things require very large number of samples. And so there's reasons to be skeptical that that's ever going to lead to true AGI. But of course, there's alternative LLMs isn't the only game in town. There's other methods of doing artificial intelligence. And so I guess the question is, will we devise some other method that outstrips ChatGPT in the future? Maybe OpenAI probably already have something they're working on to that effect, I suspect. Yes. And so that's a question I can't really answer. But it's not obvious that it's demonstrably true that we are, I think we have to accept it's not necessarily true that we are smart enough to create something that is as smart as us. It might be true that we are clever enough to do that, but it's not necessarily true. In the same way that it's not necessarily true that everything in the universe is comprehensible. There may be things about this universe that we never understand, that there are just laws of physics we never discover or truly get our minds around. Why should it be that this primate brain is capable of discovering everything? That we're omniscient. That's a little bit arrogant to assume that there's nothing that we cannot understand. There must be limits to our comprehension. And so it is perhaps possible that this is an example of that. Or indeed, the social will or impetus, the political impetus to develop something like this starts to, prevent it getting all the way to that level of development because lots of people have very serious safety concerns about this technology as well. So I can see multiple reasons why it's not obvious to me that an AGI, a true simulated reality, is an inevitability. Maybe that's just me being optimistic and hopeful because I don't really want that to be true. But I think just keeping it is plausible that is not possible, and so I'm just keeping that window open in the discussion.
It'd be interesting to get your definition of life, but life being something where you need to feed and you reproduce and you evolve, and there's certain elements of that aren't possible when we take away our humanness,
which has enormous ramifications, of course, in the search for extraterrestrial intelligence. Right. If it may be that we are in a transitional period, that we have humanity's like a 1 million-year-old species, right? You could take a human from certainly 100,000 years ago and take one of those babies that was born 100,000 years ago and put it into modern society, grow it up, and it'd be indistinguishable from any of the human. And so that's strange because civilization only really developed about 10,000 years ago. So for 90,000, even longer than that, if you go back to Homo sapiens, you have a very, very, very long stretch of time where there was very little apparent development in our technology or ability. It's certainly not the scale of development we're seeing in the current era. If you look at today, like anything, energy usage, transportation, food, the amount of food we're growing, demographics, like the number of people born, all of that's just exploded, right, over the last 100, 200 years, and even further back, probably 1,000 years. And so that's not sustainable, right? You can't just have exponentials grow forever. Something is going to change. And maybe that means there's some population collapse in the future. Maybe that means we spread out to the stars and we leave this planet altogether. Or maybe that means we all download our brains into some other platform. But certainly you can't just have unsustainable exponential growth forever. I think that's interesting. We live in a time that I think historians, if they exist, would look back and think that was a very interesting part of history where things were really rapidly changing, and it must have been very confusing for people to have lived in that time with so much happening around them so fast, trying to figure out the future of what was going to happen. I certainly feel that way in this society.
Yeah, there's a certain amount of entropy that does feel like is wrapped up in that. But on the other side, there's also so much growth too. There's so much polarity, like so much duality, like the equal and opposite there. That's what it feels like to me.
Oh, absolutely. Yeah. I mean, it's hard as a scientist. Obviously, we don't really suffer from the same kind of polarization that we're seeing in kind of culture wars and political spectrum that we have in this country and others across the world right now. It is, I think that's always what's attracted me to it, that there is an objective truth, and in principle, we should all be able to do experiments and verify that each other's experiments and agree on factual truth. And it's getting harder to agree in society on facts, right? People don't even accept facts anymore. And I'm not surprised, because you go into Facebook or Twitter and there's so much information that disagrees with each other striking you that you don't have time to check all this information. And so there's so much trust and faith. You tend to follow sources that you think are credible. And, there's a lot of bad actors out there who I'm sure some fraction of everyone we follow is a bad actor. We just don't know what that fraction is and probably are misleading us. And it's incredibly challenging to make sense of the world these days. I feel I have 2 kids, and I think the world was so much simpler when I grew up than the world they're growing up in. Just the fact of phones alone, right? Kids these days are obsessed with their phones, and they're bombarded with TikToks. And I mean, we talked about sort of AI, and I mean, one of my biggest concerns about AI and young people is kind of like hacking the brain. I don't see like a Terminator future where Skynet takes over. I think it's more like TikTok. TikTok is a hack. It's like when you go to the casinos and you see these people just staring at those screens, pushing the button over and over again, like in a trance. And those machines are sort of like a hack. They've tapped into some kind of feedback loop in the brain that the people can't get out of. And TikTok is an incredible algorithm because it seems to be able to reproduce that same effect. And I worry that an AI will master that algorithm, and it will understand our brains. It will reverse engineer us, basically. And it will find, there's an idea called the static tape. A static tape is the idea that there's something that you so badly need to listen to or watch to that you'll be willing to chop your hand off to keep listening to that thing, because it's so addictive. There's nothing else you'd rather do than have that material being ingested into your brain. And I kind of worry about that more, that we are going to be hacked, and we're going to be basically like warm goo in the hands of whoever controls that algorithm at that point, right? They can just basically get us to believe whatever they want us to believe.
Right.
And so science is, Sagan said this, science is a candle in the dark. It's a way of trying to find objective truth in the world. And that's why I think it's more important than ever, the scientific method and the way it thinks about how to approach the world. But it's challenged by the fact that there are so many things to test and prove that we're being overwhelmed, right? You can't physically spend all your time pursuing the scientific method for every question. There's just too many things to prove, and it's coming at us too fast. So I don't have a good solution for that, but it's something I'm sincerely concerned about.
I interviewed Neil deGrasse Tyson years ago, and one of the things that he said at the end was that he feared most that he didn't know the right question to ask.
Mm-hmm.
Right.
Mm-hmm.
And that is a real problem, right? Like you just don't know what you don't know. So I'm curious, just talking about sort of application of science and learning and exploring and what is objective truth and what is not. What the hell is even objective truth, to be honest, to some degree. But where do you differ in your perspectives between what you believe about the way the universe works and Neil?
I'm not sure. I think me and Neil would probably have to sit down and hack that out to figure out where we're different. I'm sure we have differences in some things, but I suspect we're probably fairly closely aligned because obviously he's an astrophysicist, the same, cut from the same cloth as myself. So
I did have to look up what the difference between an astrophysicist and an astronomer was. I was like,
yeah, well, people argue about that as well. But yeah, I think we could probably blur that line a little bit and just say that we probably think about the universe very similarly in terms of we want to have testable evidence. We want to have hypotheses that we can interrogate, that we can have independent verification of, that could make predictions that are testable, and then use those tools of science to improve our society and to improve our world, to make better decisions. To me, that's kind of the foundation of what science is all about. I suspect most scientists, not just me and Neil, would probably feel similarly about that. Maybe they'd reword it slightly differently, but I feel like that's kind of, we're all on the same page with that. I think the challenge is just in modern society, you can't really do it. You can't go around. People say, like, do your own research, but you can't do your own research on every topic. There is just physically too much information hitting us to skeptically interrogate everything. And so it is necessary to trust experts. You have to trust experts on some things. If you go to the doctor and he recommends that you take a certain drug or something, you might do a little bit of reading on that, but you're not going to go to medical school and do a 5-year degree to make sure he's absolutely correct. You just don't have the resources of the time to verify everything to the nth degree. And so we live in a society where we do have to trust experts, and that has been abused. I mean, there's many cases of scientists abusing that trust for personal gain, for personal, to sell books or whatever it is, or to get their name out there and get some personal credit for whatever it is. And that's happened in history many, many times. There's always snake oil dealers. And so I think we should be skeptical, but I think we should remember that the vast majority of scientists are in this because, believe it or not, we actually just love the subject and we love finding out about the world. All the scientists I know are driven by just those basic questions, those basic curiosity questions about how the world works. And so I appreciate you shouldn't trust everybody that you come across, but if you hear that 9 out of 10 scientists are on board with something, that's probably means that it's very likely true. We can never be in science 100% true of anything. And so the idea of even a fact, we say like climate change, sometimes that climate change is a fact. Climate change, we have overwhelming evidence that that is what is happening. It's man-made climate change. But really in science, we could never say anything is 100%. And that's unfortunately, that's just the way science is. I can never say, if I hold up this glass and I drop it onto the table, I can have 99.99999% confidence it will drop to the table, but I can't be totally sure. One time, one experiment, the glass might go up into the sky, and that would be really interesting if that happens. But that's just the nature of science, that we don't have absolute confidence in anything. Everything is a theory that we only ever get growing evidence for. And so people sometimes say, well, it's just evolution is just a theory. Climate change is just a theory. Everything in science is a theory. Yeah, it's just a theory with overwhelming evidence at a certain point. And there's also theories with very thin evidence. And I would say, aliens being UAPs is one with thin evidence, whereas, dropping a glass and it falling to the table is one with very strong evidence. Right. And we want to improve the evidence on those weak cases so that we can have clarification. And that's kind of the point of science, is to nail down either way what the truth is. So that's hard in a modern society because, I can't, if I have a question about UAPs, what do I do about that? I have to either listen to government sources, I have to, or the whistleblowers, for instance, I have to listen to skeptics who maybe feel the opposite. But it's probably unlikely I'm going to, go onto the USS Nimitz for a week and bring all my observational collecting instruments and be able to do that experiment and devote maybe 5 years of my life trying to figure out the answer to that question and get permission to answer that question. And of course, that's true of all of us. And so we have to defer to experts. And that's where the kind of Twitter and Facebook and things have sort of fed this culture war of just being fed iteratively the stuff that you click. So if you are drawn towards stories that are convinced that aliens are indeed the cause of UAPs, you're more likely to be shown things of that ilk again, and vice versa, the other way around. If you're more of a skeptic, you're going to be shown more skeptical stuff over and over again, and so it pushes people either direction, as of course we know politically. And so that's hard. It's social media has made the process of science and science communication both easier in some ways, but extraordinarily more difficult in other ways.
Do you think at any point that the school books that you learn from when you go are going to have to change? That there's a bit of maybe some chatter that I've heard in the scientific community that there's sort of conventional scientists, and then there's some more progressive scientists that might be using theories and ideas that are a little more esoteric. Mm-hmm. Do you feel that, or is that just something that maybe because I'm so interested in the esoteric that I hear about and I experience with the people around me? Or do you think that at some point in time, the books will have to change? They're going to have to rewrite some things because science is evolving, just as we are, and we learn, and you have to correct along the way.
Yeah, I think I want to quote Sagan here. Sagan said, "Science is not a body of knowledge; it's a way of thinking. Science is not the words and the laws of gravity and things like that are printed in the textbooks. It's the approach of thinking about the world that really defines the scientific method. And so, by its very construction, it is almost opposed to religion in not being dogmatic. There are no 10 commandments. There are no truths. There are no fundamental things which are never questionable. Everything in science is up for grabs all the time by anyone. And that's kind of what makes it amazing. It doesn't matter who your dad was, how many Nobel Prizes you won. Everything even that person says is up for grabs and should be skeptically interrogated. And they don't get a free pass that everything they say is therefore true. Everything is questioned. And so that's the power of science. And by definition of that construction, because there's no dogma, everything does evolve. Knowledge does evolve. And that's certainly true. I mean, if you go back to, let's say, like the 18th century, the number of planets in the solar system, I think, was like 13, 14, because it included Vesta, it included Janus, it included many small asteroid objects that were being discovered. They were all considered planets. And then they ripped up the textbook and they said, actually, you know what, we're going to redefine a planet. And now we're going to just have 9 up to Pluto. And then, of course, 10 years ago or so, we did it again and we ripped up the textbook. So yeah, the textbook's constantly changing because our information is growing. I mean, we thought Pluto was the end of the solar system, which it was back then as far as we knew. But then we discovered actually there's like 10 other Plutos of even bigger size than Pluto beyond that. And these things all seem to be quite different. And, I don't know, I don't really care whether we call them planets or not, to be honest. It's like a rose by any other name still smells as sweet. But there is new information, and that new information should be reflected in the textbook. So I would certainly expect textbooks to evolve. I suspect there are certain things which will never, which are almost not immutable because we cannot question them, but just are very unlikely to change. So if I took like the second law of thermodynamics or something, thermodynamics is something that is extraordinarily well established and tested, and it would be pretty strange if conservation of energy was totally wrong, or if take a quantum theory, some of the bedrocks of quantum theory, such as the Heisenberg uncertainty principle. It'd be strange if that was false, but I I suspect our knowledge will increase, and maybe some of those things will be shredded up. And that's the beauty of science, that it is amenable to doing so. But I think there will be a seed of truth that was true. You go back to Isaac Newton's Principia. There are many of those laws that we still teach in our textbooks today, and it's not that it's not that knowledge stopped after Isaac Newton got going. We've learned much more since then, but there are certain truths that he realized that are still true today, as far as we can tell. And so knowledge is evolving. I think our textbooks will evolve, but I hope we don't burn all the textbooks, as has been happening in some states, of like throwing away all this precious knowledge, because it is the product of this extraordinary journey of knowledge acquisition about the universe. And I hope, one thing I worry about, we've got this seed vault that I think it's in Sweden or something, or Norway. And if you know the Foundation series, they by Isaac Asimov, they kind of have this idea of putting all the knowledge somewhere. And I kind of feel that way with humanity. Like there is a risk of us destroying ourselves through nuclear war, through some kind of nanotechnology or something, or AI. And so it's hard to imagine what the threat could be, but there is clearly possibilities of destroying ourselves. And it may be that there's a reset that's going to happen and civilization gets pushed all the way back to the Stone Age. And it just, to me, it'd be obvious that we should leave some resource for those people to get ahead of the curve, because even if it's a 1% chance, it's not much effort for us really to just, make sure that information is stored somewhere, because that is the product of billions of minds over history, of the most brilliant minds working on problems for their entire life to try and discover things. Some of that stuff will be wrong, but it'll give an extraordinary head start to whoever picks that up.
Well, we're where we are now because of people like you and scientists, so we definitely need scientists. But also, if we are reset, which we could be in what could be called the Great Reset right now, not knowing what that really means, but just words that float around. I mean, we would need to know how to read it. We would need to know how to decode it. And it feels like there are things left behind that we don't understand, can't decode. We think we know what the hieroglyphs mean on the, walls of the temples in Egypt and various different things. But we don't really know. We don't really know how it's all made. So even if we leave something behind, we still have to reach a level of intelligence where we can understand it, which leads me to a curiosity I've been learning a little bit more about lately, being the 3 types of civilizations and just sort of how humanity evolves. And so it feels like that's something that we need to do as a civilization, so we don't do things like push the nuke button on each other. Like that is an idiotic thing to do if we want to survive. So where are we at, and what are the 3 types?
Yeah, I think you're describing the Kardashev scale. So there is Nikolai Kardashev was a Soviet physicist, astronomer, who thought about a way to classify civilizations in terms of their energy use, which certainly made sense at the time, but since people have challenged whether that's truly the quantity that we should be looking at. But anyway, the basic idea that he had was, if you look at energy growth on our planet, it's more or less been increasing by about 2 or 3% ever since, even really pre-industrial times, it's been increasing by 2 or 3% per year. So if that keeps going, there's a certain point where we use as much energy on this planet as actually strikes the Earth from the sun, which is a lot. And we're using probably less than 1% of that amount of energy that strikes the Earth is being used right now by human civilization. And not just used in terms of solar panels, but even the energy we're digging up from the ground, like fossil fuels, and burning them. If you add up all that energy, it's way less than the amount of energy that strikes the Earth from the sun. Which, of course, hopefully makes sense, because most of the energy striking the Earth is used by plant life and to warm the atmosphere and stuff like that. So if we used all of that energy, there'd be no plants.
Exactly.
They'd be in trouble. So they want a bit of that pie as well, right? It's not just all for us. But the idea was that there was a certain point where that would happen, and obviously civilization the planet would look very different in such a scenario. And so we call that a Kardashev type 1 civilization on his scale. A civilization like that would probably have the ability to control everything in their planet in terms of the atmosphere, the weather, protect from solar storms, maybe even the geological activity. And so they would have complete command of the planetary domain. And then going further, if this growth continued, of course, the only way to get more energy would be to go into space and to build structures off-world. And eventually you might try to harvest all the energy from your star. This is why I kind of love solar power. Think about Kardashev's argument. If you wanted to collect the most energy possible, the obvious thing to do would be to build a shell around the sun, because that is a nuclear fusion reactor, right? It is not only a nuclear fusion reactor with enormous amounts of fuel and energy, it is one for which the problem of confinement is solved by gravity. So when we try and build fusion reactors on Earth, the big challenge is, how do you get all that stuff into a very high pressure? And it takes us an enormous amount of energy with magnetic fields and things to squeeze this stuff together. And so we lose a lot of energy in trying to create fusion. The sun does that kind of for free, thanks to gravity. So gravity, just mass, I mean, that's almost like free energy in this sense. It's kind of squeezing things together, creating those pressures. And all of that energy is being released into space. A tiny fraction hits the Earth. If we harvested that, that would be kind of the ultimate amount of energy resource we could imagine in the solar system. So this idea is called a Dyson sphere, after Freeman Dyson, a physicist who first suggested it. It has evolved since. I mean, we kind of think it's probably not very realistic that you would build a solid structure. That seems unstable. If you had a solid structure around a star, all you'd have to do is give it like a little boop, like a little push, and the whole thing would just fall into the star.
Yeah.
Right? It's not very stable. So that seems like a problem. It would actually be much easier if, instead of building a giant structure, you had lots of little satellites that almost formed like a swarm, and they all orbited around the star. That would be far, far more stable than, and you wouldn't need any kind of super strong materials or anything either. So yeah, you could certainly imagine harvesting all of that energy. And we have actually conducted experiments to look for those structures. I want to point to work by a colleague of mine, Jason Wright at Penn State. And they've surveyed about 100,000 galaxies, looking for galaxies which have basically been, all of the stars have been enshrouded with these Dyson spheres, and they don't find any. And similarly, there's been work looking for about 100,000-ish stars in the local galaxy, asking if any of them have these Dyson spheres, and none of them seem to do either. That's kind of it. That's interesting, because this is apparently, as far as we can tell, if you wanted to generate that amount of energy, this is the obvious way you would do it. Maybe at a certain point, civilizations get enough and they're like, we don't need any more energy. But obviously, energy for us has always been the enabler. If you want to lift a rock from the sea level to the top of Everest, there's a fundamental amount of energy that the potential energy change that dictates how much you have to do that. And it's not really a question of efficiency. No matter how efficient you do it, it's always going to take at least that amount of energy. So the amount of work you want to do is always going to be restricted by your energy availability. So I think it certainly makes sense, if you want to do amazing things in the universe, you're going to need that amount of energy one day. And the final step to this is a Kardashev 3, which I kind of already alluded to, which is when you harvest all the energy from a galaxy. We don't see any evidence for those in the local universe. That is interesting that those don't exist, apparently don't exist. It may be that they are very clever in masking those signatures and we're not able to detect them. But again, this kind of comes down to thermodynamics and waste heat. It's kind of the same as like your laptop. Your laptop takes in power from the outlet in the wall, or from its battery, and it uses that to do some kind of computation. And then that computation produces waste heat, and that's why your laptop feels warm on your legs or on your hand if you touch it.
From the energy.
And there's no way around that. If you do any work, as far as we understand with the fundamental laws of physics, whenever you do work, which is to say you're using energy to do something useful. If you're not using energy to do something useful, I mean, what are you doing? You're just not doing anything. You're just sat there twiddling your thumbs. But if you're doing work to do something, energy to do something useful, then you always have to produce this waste energy. And so it should be detectable. Energy is obviously something we can look for in the universe. And so I think it would be, it's kind of strange that we don't see these.
We should harvest that. We need to harvest the waste energy.
Right. I mean, people always say that, but the problem with waste energy is it's not usable. Yeah, it is kind of like garbage. So you can basically only, if you want to build a computer or any kind of energy harvesting machine, or machine to do work, I should say, which is useful useful energy extraction, it's always governed by temperature differences. This is called the Carnot cycle in thermodynamics, developed by I think an English engineer who just was working on thermodynamics in the sort of 18th century. So we're going way back. And basically, the amount of energy you can extract is always governed by two temperature reservoirs. So in our case, the temperature reservoir is the sun. The sun is about 6,000 Kelvin. The Earth is about 300 Kelvin. And so there's a huge temperature difference. And so that temperature difference allows us to extract a huge amount of useful energy, which is how solar panels work. Yeah. If I then use that waste energy for my laptop, the waste energy comes out at about 300 Kelvin again. So now you've got no temperature differential, and so you can't do useful work. If you built another shell further out where, you get down to where space is really, really cold, then sure, you could do work there. It'd have to be a gigantic shell to do that. But then again, you're going to make waste energy that would now be even colder, and again would be even sort of more useless. So it's kind of a unavoidable fact that if you're doing probably the best place a computer would live in space would be the very depths of space, as far away from a star where it's cold as possible. That's why we build our data centers in the Arctic and Antarctica and these polar regions, because where it's coldest, you get the highest efficiency for your computation. And so the same way, it's interesting to think maybe the place to look for super advanced AI intelligences would be in the depths of space, very, very far from stars, where you would maximize that temperature differential and be able to extract the most useful work.
Energy for longer.
You get more bang for your buck out of the energy. Yeah.
I wanted to ask you only one more question, but then you said Antarctica. Is there anything significant about Antarctica other than the fact that you just told me that they build huge computer bases in Antarctica?
I mean, I don't know. The Antarctica, what worries me about Antarctica is just the amount of ice sheet that we're going to lose off that damn thing as the planet warms up. So I do worry about the huge ice reservoir that we are slowly chipping away on that thing. It could be obviously useful for computation. I think some data centers are trying to go up there. It is useful in astronomy because the polar regions, you probably know this, but if you're in the Arctic during the winter, you get not quite 6 months, but you get many months, I think 3 or 4 months of complete darkness. Mm-hmm. And so that's useful to astronomers if we want to, collect a video of the sky and observe the sky. It's kind of annoying when it's daytime because unless you're doing radio astronomy, you can't observe the sky anymore. Whereas in Antarctica and Arctic, you can observe for many, many months continuously. So there has been efforts to build large telescopes in those regions. Unfortunately, they often really struggle with the extreme conditions because it's kind of strange that our technology only seems to work at room temperature, which is maybe not a coincidence, but basically whatever we build down there kind of gets gummied up with ice and stops working in fairly short order. So we don't really have any very large successful surveys down there which have really changed the game, but it is an extraordinary opportunity, perhaps as we improve our ability to build structures in those kind of climates, that we could have access to the sky in a way that we don't currently have. It's also good for getting around Starlink. You probably know Starlink is an enormous problem because it produces a lot of light pollution for astronomers looking up at the sky. But Starlink has basically no coverage over Antarctica because there's no customers there. So there's no satellites really. There's very, very few compared to around North America. Yeah. And so it's a good place to escape the satellites, satellite light pollution as well.
Well, I guess we were doing something wrong then having Starlink at Burning Man so that we could have some cell phone service. So,
well, what else? Yeah, unfortunately, what else are you going to do? I mean, they're already up there. So, I mean, yeah, I totally understand. But it's, I hope you weren't washed out by all the weather.
It just made it more interesting, to be honest. Right. It's like memorable, right? You'll never forget that one. You'll never forget the 23, flood, basically.
I had that with Glastonbury one year. Yeah, back in the UK, we had a similar year where it was just like up to your knees. But I think it was probably even worse at Burning because you guys aren't used to it. But it was an interesting, memorable experience.
Yeah, exactly. Is Glastonbury worth going to? I've heard it's amazing.
Yeah, I've loved every time I've been there. It's been incredible. I haven't been there for probably 8-9 years though, so I'm not sure if it's evolved since when I was going regularly, but the music is absolutely incredible there, and the energy, it's wonderful. It's the best UK festival in my opinion. Yeah. Burning Man is a special one too. If you've never been,
it's very unique, very cool, and something to see. It's pretty ineffable. You have to kind
It's on
of,
my bucket list.
yeah, you have to really see it for yourself. I just wanted to ask one more sort of curious question, and I know I'm going to kind of stretch you as a scientist to sort of give an opinion, but based on parallel universes, multiverses, all the different potentials, simulation theory, base reality, like if you were to sort of put pen to paper and go, this is how I want our reality to actually be. Like, this is what I hope that we discover for humanity and for the way things really are. Like, what would you hope? What would be written down?
There's so many technologies that I wish would exist and would be potentially transformative to humanity. I think, Star Trek does a really good job of laying out a template of what some of those technologies might look like. Things like the replicator, a way to basically 3D print food and remove the food crisis, having fusion power or some other, like the antimatter engines they have in Star Trek, some of the energy source that could remove our dependency on burning fossil fuels and damaging our climate. And, the more advanced ideas of being able to travel between the stars. I mean, when I looked up at the stars, that's what I wanted to do. I didn't just want to look at them. I always imagined that one day I might have the opportunity to visit them and step foot on those other planets. And, growing up, I've realized that's less and less likely to be true. But it's something that I think has always driven us as a species, is to explore the next frontier and go to the next world and see what's around the corner. So if there was a way for us to travel between the stars one day, and yet at the same time protect our home and give everybody a fair and equal chance of life, that would be my bright future I would hope for. I know that's a tall order to ask for all of those things, but the amazing thing about the human mind is that there might be limits to our comprehension, but as far as we can tell, there's no reasons why we can't solve many of those problems that I've described. And so I'm always blown away by the ingenuity of my colleagues and people in other fields, of these brilliant people who are trying to push the envelope in so many different ways. And it gives me a lot of hope for the human race, that we can think of our way out of these problems. And ultimately, as long as we believe that, I think it's true. I think the moment we stop believing that we can solve our problems is sort of the end of the road for us as a species.
Oh.
And so I think it's important that we keep that faith that we can get ourselves out of this problem. And we certainly have a lot of historical precedent to believe that we are smart enough to lift our species out of this. And what an incredible future could lie ahead for humanity if we do.
What a time to be alive. Thank you for all your hard work. Thank you for the time today. I agree with that reality. I hope the same.
Thank you for having me.
Thanks everybody for listening to the Pretty Intense podcast today. I hope you enjoyed it. If you like what you heard today and you want to hear more, please click on the subscribe button.